Hello everyone, and thank you for attending this session. We will talk about PbTest, a simple framework for unit testing of PowerBuilder applications. Here is the usual disclaimer. Everything we'll talk about is made by volunteers. A peon has no responsibility about anything, and all copyrights must be respected. Use this presentation and its content at your own risk. Okay, so what will we talk about? The main topic of this session is unit testing. So first of all, we'll see what unit testing is and what is not, and why is unit testing important for our work as developers. We will then talk about the tools we need to start unit testing our code, and here PbTest will come in. We will see how to set up it and how to write and run tests with it. We will show it in practice on my machine. PbTest also has the capability to be executed from the command line. This is useful for CI integration, so we'll see how to do that. Finally, I'll say just words about the internals of PbTest, how it works, and how anyone can extend it. Here I am. My name is Luca Arena, and I'm from Italy. I am a software architect and a developer's team leader. I have been using PowerBuilder for client-server development since 1996 with version 4. I am also a full-stack web developer with PHP, Java, and JavaScript. My job is to design and write client-server and web applications. Just words about the company I work for. Its name is Omicron Sistemi, and it is based in Milan, Italy. It was born in 1985 and has more or less 500 customers for 1 million euros revenue. We build and sell business software, especially for waste management, accounting, store management. We also build software for charity organizations. I am also one of the founders of AUGI, which is the Italian Appian user group. Its goals are to share experiences about PowerBuilder and other Appian products, mainly online, but also offline. We try to spread the word in Italy about PowerBuilder and also make business and help each other. Okay, so now that the presentations are done, let's talk about testing. As software developers, we need to test our applications. We have to guarantee the quality of our software and prevent crashes and sleepless nights. But our testing activities should also be automated. That's because manual testing is, to name just a few, repetitive, boring, slow, costly, frustrating, error-prone. So, okay for testing, but we need to automate it. There are many types of automated testing. We'll just mention 3 of them. QA testing, also called functional testing, is a type of testing that is usually focused at testing the application as a black box. Starting from the UI. Tests are written and run by QA engineers using capture and playback tools. They are very slow to execute. You can see the testing application running the UI and writing and clicking on the screen like a human. Integration testing is a way to test single features of the application in isolation, but in production-like scenarios. It's not mandatory to execute tests from the UI. Tests can focus on business logic and can be executed directly if the code is designed to do that. Tests are written by both QA engineers and developers, and are usually slow, since they need to connect to databases, web services, file systems, and so on. Unit testing is the most atomic type of testing, as it focuses on single classes methods of the code. It is written entirely by developers, using specific tools, and it is very quick to execute since it focuses only on business logic. Now let's focus on unit testing. What is it exactly? Unit testing is writing and executing repeatable tests on single classes and functions of the applications. And it is testing business logic of the application. Okay, so we focus on single classes and on business logic. Unit testing is not debugging. It has running the applications and see if it works. This is not unit testing. It is not testing from the UI with some capture and playback tool, as this is QA testing. And it is not writing tests that involve databases, file, web services, UI components, device drivers, and other things external to our business logic code. All of this is integration testing. So why is unit testing important? Unit testing is important, first of all, as a QA tool. Unit tests are quick to execute and also to write, and they fix the behavior of our components, so it is harder to incur in regressive bugs. And they are good at finding the exact point where the bug is because they are very specific. Unit testing is important also as a design tool, because unit tests force us to decouple our business logic from external components like UI, files, databases, and web services. If we unit test our code, we tend to develop little independent components that do just one thing, so that our applications are easier to maintain. Unit tests are also good when we want to refactor our code, that is, improve its structure without changing the behavior. They are a safety net, checking that we don't break our code while refactoring. So how we do unit testing? Here is a simple process made of 3 steps. Let's see it. To start, we have to set up a testing project, as writing unit tests is just writing PowerScript code. If we use testing frameworks, we have to include its libraries in the project, in the test project, of course. Next, we write tests that are NVOs in PowerBuilder by inheriting from the framework's ancestor objects. Finally, we run tests and see the results using an application called Test Runner. This is the visual way of using tests, but we'll see that we also can inspect the results of the tests in an automatic way in a CI framework. Okay, so it is now clear that we need a unit testing framework to help us to write and run unit tests. PbTest is one of them, specifically designed for PowerBuilder. It is open source and 100% PowerScript code. It is inspired to XUnit, which is a class of agile unit testing tools that's a de facto standard. There is another project called PbUnit, which is in some points similar to PbTest. And PbTest is aimed at testing business logic, that is the NVOs and global functions. It supports grouping tests in suites, so we can execute a bunch of tests all together one after the other by grouping them in suites. And it has a visual test runner, okay, but it can be executed also from the command line. So it is rather easy to integrate in CI scripts. And finally, it is very easy to modify and extend it. So let's see how to use PbTest. First of all, we have to download and unpack it. We then need to create a unit testing target for our application and put it in a test people. Next, we put all the peoples of the real app in the library list of the new target. And of course, we put also the pbunit.pbl library, which is the library that contains the framework. Then we need to create at least a suite that is an object that will group all the tests by inheriting from an PbTest suite. We will see then in practice how to do this. And we also need to create an ini file that is necessary to tell the runner what suite will we start from. Okay, so because we will see in the next slides that we can have many suites. So these ini files is useful to tell PbTest what suite he has to execute to start as a start suite. And if we want also a nice icon when we build the project, okay, if we want to execute it from the command line, we will have to build it. And if we want a nice icon, we can, of course, also prepare a PBR file. Okay, so we built a new target and we have a new application object. And in this application object, we have to code the open event, as always. And the open event, in the open event, we have to put a simple script that is more or less this one, in which we have to create an instance of the test runner, which is an PbTest app. Okay, so we create an instance and then execute the tests with this statement. Okay, this function call. And if we want to graphically display the results, we can open the PbTest show result window. I usually do this when I run the testing application inside the PowerBuilder IDE. So we test if and get application equals 0. That is, if we are in the PowerBuilder IDE, we will open the window with the results. So you see, we have a new application that is based on the peoples of our real application, but it is a test application, and its open event will just execute the tests and show the results. Okay, so now that we have set up our environment, we can start writing tests and group them in suites. Okay, so tests and suites. I usually create a test people for each people of my real application, named test plus the name of the original people. And I also create a test object for each object I want to test, named nTest my object. This name format is mandatory to execute correctly the tests. And then what I do is that I create a suite for all the tests of the peoples of the objects in a people. Okay. I create a suite that is called nSuite and the name of the people, and this will group all the tests of all the objects of that people. So in this slide you can see some details, but all of these we will see in practice in a few minutes. So writing using unit tests is about writing methods of a test case object. Okay, so we inherit from an PbTest case. We will see them in a few minutes, and we put code inside these objects, inside its events. How? Well, each test method in reality is a test event, we will see, and is made of 3 parts, 3 blocks of code. There is this rule, it is called the AAA rule of unit testing: arrange, act, and assert. First of all, we have to create the component that has to be tested, and we have to configure it to run the method we want to test. Of course, if we are testing a user object, we have to instantiate it, while if we are testing a global function, we don't have to do that. If we have many test events, we always need to instantiate our object, we can do this in the setup event, and it will be executed automatically for each test event. With the act, we call the method of the object that we want to test. So we have created the object, configured it, the object that we want to test, and then we call the method we want to test by passing, of course, the right arguments. And with assert, we check the result of the method and see if we match it, if it matches the expected result. Usually this is done by calling assert functions that are ready in the framework. Okay, so we can call them. And of course we can test the results, but we can also catch any exceptions that we expect our code to produce in case of errors. Okay, so let's see first unit test example. We have a global function that is called fStartsWith that just checks if a string begins with a prefix. Okay, so if this is true, the function returns true, and otherwise it returns false. Okay, so we want to test a side case. We want to test if the function returns true if the prefix is empty. Of course, if the prefix is empty, this function has to return true, because any string begins with an empty string. Okay, so we create an object called nTest fStartsWith. fStartsWith is the name of the object, the original object, original function, and we put nTest before the name. Okay, and we inherit it from an PbTest case, which is in the PbTest pboard. And we code an event, an user event, called test returns true if suffix empty. So we have to start the name of the event with test underscore, and then we can put a name that tells what kind of test we are doing. We are testing that the function returns true if suffix is empty. So here are the 3 steps inside the code. We don't have an arrange step because we have a global function, so we don't have to instantiate it. But we have the act when we call in which we call the function fStartsWith with the arguments that are needed to test this case. So this is the string, and the second parameter is an empty prefix. And then we assert, we test, we check that the result of this is true by calling of double underscore assert true. Double underscore is a convention that I use for protected functions. So I use of double underscore for protected functions and of single underscore for public ones. So that's just a convention. So if the functions the f starts with is good, this test should pass, and we should see in the visual runner, in the visual test runner, a green bar stating that the test has passed. We will see then in practice. Let's see another example. We here have a different object that is an ndict object, which implements a dictionary, the data structure made of key value pairs. In this test, we insert a pair and then test that this pair exists in the dictionary. So the test object is test ndict, because ndict is the name of the original object. And we have an event that's called test exists true on added element. So we test that exists returns true after we add an element, of course, if we check for the same element. So here we have an NVO to test, which is ndict. So we have to instantiate it and also to configure it to add some data to it. We are adding a couple of values, a pair that is made by the telephone prefix of Italy and the name Italy. Okay, so this is the key and this is the value. And next we check, after we add it, we check that exists returns true for the same key. So we call this function and then assert that is okay. Of course, if the object is correctly running, this test should pass. Okay, so we saw a couple of tests, but I want to show how to realize, how to code them in practice and how to execute them. So let's start with the demo. Okay, so let's see how to use PbTest in practice. Here we have PowerBuilder 2019 and we have a demo application that I wrote for this session. It is a simple application that shows weather forecasts. So it lets the user select the location from a list that is stored in a UNI file, and he can choose the date to have the forecast and just click on load forecast. The program connects to a free web service, HTTP web service, and downloads the data about the forecast and shows it in a data window. So nothing difficult. These are the pbuilds of the application. As you see, the application is rather decoupled as we have different objects to do different things, such as load locations, weather codes, the window, and a location structure, and so on. This application has a Meteo utils, so a utils library which contains the objects that we saw in the slides. So F starts with an ndict that are used by the application. For instance, weather codes is inherited from ndict. Okay, so we will then test these two objects, the two objects that we saw in the slides. So first of all, we have to download PbTest. So let's go to the browser. This is a URL. Okay, here. Download zip. Okay. and we put this near our application folder. Okay, this is the first thing. Okay, now that we have downloaded it, we have to create the test target inside the same workspace of the original application. We can call it test meteo. So, PowerBuilder, new target application, okay, test meteo. Okay, and we can copy the libraries from the original application, because we will have to test these objects. Okay, and this one we don't have to put because it contains the application. We don't need it. Why we need the test meteo. Okay, and we also can add the library of PbTest. Okay. Okay, this is the wrong target, I guess. So, library list, copy, library list, okay, that's okay. This one, not, and then PbTest.people. Okay, so we have a new target with a new application and the peoples from the original one. Now let's create our first suite. I always create an all suite that executes all the other suites. We will call it nSuite all and put it in the main people of the test application. So let's inherit from here, PbTest suite, file, save as, suite all. That's all for now. And now we need to create the ini file, which tells the runner to execute the all suite. So, meteo we have meteo.test.ini. Okay, you have to start from here. So, our configuration is done. No, it's not done. We still have to code the application event of the application open event. So let's do that. Okay, here it is. Okay, now we are done. Wonderful. Status success. No tests, since we don't have any tests yet. But our application, our test runner is running. Our test application is running well. So it's time to create our first test. Let's create a people for the tests of these people. So new library test meteo utils. Okay, and now let's create our first test. We inherit from npbTest case, save as here as f and n test f starts with. Okay, since we want to test this function. So this is the right name for the test. Okay, a new event. But here I will copy and paste, so we go a bit faster. Okay, this is the same code we saw in the slides. Okay, what it's doing, check if we pass a prefix, not a suffix, prefix. This is empty, this should return true. Let's save it, run, nothing. Why? Because we don't have the suite for these people, and there is no point where our test is being called. So let's create the suite for these people. Okay, file and suite media. Okay, and this suite has to execute our test. Note that we don't have to put end test before, because the framework knows that all the test objects starts with end test, so it's not necessary to put it. Okay, so now we have this suite, but if we run, still nothing, because our runner is running this suite, okay, and suite all. So we can change the ini file to start this other suite, or we can make this suite call this suite, which is the right thing, because this is the suite that runs everything. So let's do that. Execute suite media utils. All right, and suite all, this suite is running this other suite, and this other suite is running the test. So it seems to be very structured, but this is since we have just one test. When we have thousands of tests for each of our objects, this structure is not that big. It's necessary to separate tests, to organize tests. So our first test is passing. Let's modify it to see if it fails. Okay, just for instance, assert false. Okay, we can also use this way to assert that this is false. Okay, failure. Right, because it is not false, it's true. Run, good. Wonderful. I guess we can do another test. Let's check another side case. What if the prefix is null? We expect the function to return true only if the string itself is also null. So let's write a test for it. Okay. Add this is the test name, and this is the code. So what is it doing? We check that if we pass ls null, so a null string as a prefix, it should return false, because test doesn't start with null. So let's see if it works. It doesn't work. Okay, why doesn't it work? Because our function is not testing the null case. So this becomes null, and of course this is not working. Okay, so we have to modify our function to manage this side case. This is the function, and we have to put this correction here. So if the needle is null, then you have to return null. You have to return true only if also the haystack is null. Okay, and otherwise we have to return false. So now it's working. Wonderful. So we can add other events to the testing object to check for other cases. And all of these tests will be also available to execute and check that our function is still okay, even after factorings or other changes. Okay, now let's test the other object and dict. So we need another of this file, save as. Okay. This is not the right position here. Okay, let's add it to the suite. Okay, run. Okay, there are no test cases here, there are no events. So let's put an event. Add. Here is our test, and this is the name of the event. Okay, so we are doing the same thing as in the slides. Run. Okay, passed. It correctly finds this element in the dictionary. If we try to modify, okay, it fails. That's right. True. I'm back. Working. Let's make another test. For instance, we can check that the count method works as expected. So, for instance, we do this way. Add 5 elements to the dictionary and then test that the count is 5. I've put 4, so it should fail. This is the name, test count 5 with 5 items. Run, fails. Actual 5, expected 4. So the expected is wrong, so let's correct it. Okay, it passes. Okay. Now, we have made enough examples, but let's see how do we run these tests from the command line. So we just have to create the project for this application. So new project application test meteo.exe. We already have the PBR. Select all, save. test video. We save it here and deploy. Test media is invalid. Why? Why? We didn't meet it. Oh, okay. No problem. I was sure I already made it. PBR. Okay. Deploy. Okay. I'm missing a function. This function that I used here is missing. Okay, so let's deploy again. Perfect. Save and quit PowerBuilder. So now if we go to the directory, elevate, okay, delete the result, okay, and copy the PbTest people, the PbTest PBD. Okay, so now we can execute it from the command line, test Meteo. And we obtain the result in txt. Here it is. Okay, so this is the result file. Our CI script has to check that it ends with the status success string. Maybe we can improve PbTest to create a result.ok file if the status is OK, or a result.fail file if the status is KO. So it will be easier to check it from an external script. This ends our demo. Of course, we can write tests for all the other business logic objects in the app. We can test the UI, the files and web services in unit tests, but we can try to extract all the business logic so that the remaining code is trivial. Let's go back to the slides for some conclusions. Okay, so we saw a couple of trivial examples, but in real applications, how can we start doing unit tests? A first suggestion is to start testing new MVOs and global functions. That's because if we know that we have to test them, we'll write them to be testable. On the contrary, it is much harder to start testing legacy code because it's often coupled. To the extreme, we can write tests at the same time that we write production code. This technique is called test-driven development, and it is very spread today in the software industry. We should start decoupling business logic from code that works with UI, databases, web services, and so on. How? By writing separate MVOs with business logic. For instance, if we have to validate a form, validation code that is business logic should be put in a separate MVO from the window code and unit tested. For resource-dependent code, such as database code, but also file system code, web services code, and so on, we should create fake objects we can pass to the business logic instead of real objects. If we need to do integration tests, and we will need to do that because we mainly develop business application, we can use PbTest also for that. Of course, we will have to set up a complex testing environment with all the resources, files, databases, and so on. Okay, for running from the CLI, we already saw it in the demo. We just need to create a PB project in the test target and compile it. And when we run the exe, the resulting exe, it will produce the test results files. These text files can be parsed by a CI script to look for the status success and decide to go on with build or not. Okay, so just 2 words about the 5 objects that build PbTest. We already saw them, but just to recap. PbTest app is the main runner of the tests. It reads the INI and starts the test suite, as we saw during the demo. PbTest suite represents a suite and executes other suites or test cases. We used it. And PbTest case represents a test case. It has template events set up and tear down that are executed before and after each test event. We didn't use that in the demo, but we can use them to instantiate the class under test, the object under test with a setup mainly, so that it gets created at before each test method. The magic of this one is in the OF execute test events method. Okay, so this, if you want to modify, to look inside in the internals of PbTest, this is the most important event, the most important function, because it uses PB reflection to find all the test events and execute them. And there are many assert methods, not so many, but just a bit, and you can add more. Okay, so this is one place you can improve, where you can improve the tool. Other objects and PbTest results represents the test results, and it is the object that writes the result txt file, while WPBTest show result is the visual test runner. To be fair, it just displays the result text file, so it doesn't work. It simply the runner produces the result .txt file, and this window displays it in a nice way. So in this slide you can find some links about resources that I used to build this presentation. First of all, the PbTest GitHub repository that will be very useful if you want to use this project, and then some books about and the websites about unit testing. And thank you for watching.